we understand variables now, but we're going to take the next step, because right now we only have place for one value in every single variable, and by and large that's good. But what if we want to make something that holds multiple values? Well, we can make a script specifically to hold multiple floats. That is exactly what vector2 and vector3 do. But what if we don't know how many floats we want to hold? Maybe it's variable, right? Maybe sometimes we want to have just 2. Maybe sometimes we want to have 5. Maybe sometimes we want to have 15. Well, there's a very good way to do exactly that. And for that, we're going to go over to this text update script that we've made before. This simply holds a number to display in the text in our scene. So if we go up here, it's this number has that script on it and it displays that number. So we've got this text and this number. We've got a function on it to increase that number. And what I want to do here is make this function have a couple of options. Right now, we're just putting in a single number and it's adding that number every time function gets used. But what if we want to add in a number of options like 3, 5, 8 and 9 and have it randomly pick one of those? What we could do is we could say public int number to add 1, and then we could add a comma, and then int number to add 2, and so on and so forth. At that point, we would need to make a version of this function for every single combination of how many numbers we want to add. We would have to make one with 1 parameter, and one with 2 parameters, and one with 3 parameters, and one with 4 parameters, and so on and so forth. And that's painful. It doesn't work very well. So what we can do instead is not making just an integer, but by adding simply these little square brackets, we're changing the integer variable into an integer array, which is just a list of integers. That's however long we want it to be. You might notice though that this bit of code is now throwing an error at us, because as soon as we made this into an integer array, we can't just refer to it as a normal integer anymore, because right now it's looking for an index. Every entry you have in an array called an index starts counting at the number 0. So we need to specify which index. So for now, we'll just call that index 0. There's a little issue with Unity where it can't use on the buttons, on the on-click event, it can't actually use functions that take in parameters that are arrays. So that's bad for my example. This is also a valuable lesson. This is not what I intended it to be. I foolishly didn't experiment with this before starting to record this. I'm going to leave this in because you're going to run into this quite a lot while coding your own games. Is you have an idea, you try it out, and you figure out that, oh, actually there's some weird reason that it doesn't work. And you're going to need to change course and be creative about, okay, if it doesn't work in that way, can I find another route to the same end? There isn't one solution to any given problem. There is infinite solutions to all of your problems. It's always going to be a trade-off between how easy and fast it is to make, how flexible it is to build off of for other functionality potentially, and how computing intensive it is. None of that matters right now though, because we're just going to change this around a little bit. So we're going to get rid of the parameter in the function itself, and we'll just make a integer array as one of the fields. So we'll make an integer array and we'll call that numbers to add. And then in increase number, we'll just use numbers to add, and for now, just to show you, we're going to stick with index 0. And let's also make this a public array so that I can show you in the editor what the difference is between the normal integer we have here and the integer array that we've just made. So we're now on the text itself, and we can see the number as we've used before. It's 0, which matches what we see here. But then we've got the numbers to add, which is a drop-down menu. And when we press this plus thing, you can see we're starting to make a list of different entries here. So we can say 5, 8, 12, 212, that works as well, 7, 3, 1, and suddenly we've got this list going on here. Let's actually make this 12 instead of 212, because that's a little overkill. Or maybe we want to just have 3 entries and we just want to say 1, 3, and 5. That is the power of an array. It should be noted that while I can add as many entries into this array as I want in the editor, I can't on runtime, while playing the game, add more indexes to an array. That's what lists are for, which we'll get into a little bit towards the end of this video. So now if we press these buttons during gameplay, we can see it's still adding 1, but that's because element 0 is set to 1. So if we set element 0 here to 5, now it's adding 5 with every click. But that still isn't particularly useful because we're still just adding element 0. I want to randomly add element 0, element 1, or element 2. Or if I have 6 elements, I want to randomly add one of those 6 elements. Well, we can arrange that. So we make a variable for the index instead. So we can make an integer, and that is called index, which will be equal to random.range. And this will give us a random number between 2 values. So the lowest value will be 0, and the biggest value will be, what will that be? Because that changes depending on how long our array is. Luckily, we've got a function for that existing, and we just go our numbers to add array dot length. You might get this issue as well, where random is not recognized because both Unity Engine and System have a randomness function. So we're going to get rid of this using system that every script comes up with here. And that should fix the error. Now, instead of using index 0 always, we can put our index variable into our array index here. And now it will take a random integer between 0 and whatever length our array is, use that as the index for which number to add when we press the button. So remember, our array consists of 1, 3, and 5. When we press this button, it added 5, and now it added 1, and now it added 1 again, and that's 5, and that added 3. So we know it worked. We can, through this editor, add some more different ones if you wanted to. So we can see that added 15, and it added 3, and our code works. That's the most important part. But as I said before, you can't just like add more entries to this through code, because arrays have a set length, and you can't add something to an array. You can't just say numbers to add dot add and then add a new index to it. That doesn't quite work. If you want to do that, we make a public list instead, and then in those little pointy brackets you put in what type of variable the lists will contain. In this case, it'll still be integers, and then you need to set it equal to a new list of that type, and of course you need to give it a name as well, and parentheses at the very end, because making this new list is technically a function, maybe something like that. Now back into the Unity editor, we can see this list here, and we can add indexes to it, and it seems entirely the same, doesn't it? Well, not quite, because unlike what we can do with the array that we have made, this list can actually be influenced during runtime. So we can say our numbers list dot add, and then we can add a new entry to that list. So let's just say 5 in this case, and now we'll see, let's make this list empty. Every time that bit of code runs, so every time we press the button, this list will get increased in its size with a new index that has a value of 5, as you can see. Something that we couldn't do through code with an array. Now, this is very, very powerful, but also it being able to do this means that it is going to take up more computing. So as I said before, there's a lot of ways and a lot of options to do literally anything that you can think of. You're going to have to slowly learn to understand which paths take more computing power and when that's worth it. Arrays are a bit more limited in what you can use them for, but they are also more performant. Since this is a beginner course, I wouldn't worry about it too much at the moment. If you think arrays and lists and it just feels confusing and I don't really know what to do when, eventually that will become more apparent and you can just use lists for now. That's fine. Or just use arrays and live with the fact that you can't add new indexes during runtime. To give you an example of when lists would, for instance, be useful instead of arrays, in my own game that I'm working on, I've got a monster spawner where I use an array to set which monsters will spawn, because that doesn't need to change during gameplay. But the monster spawner itself is an object that has a list on it, which also keeps track of which monsters it has spawned. And those monsters add themselves to that list during runtime, whenever they are spawned. So that way, the spawner always is aware of what living enemies are around it, and that list will dynamically get bigger or longer depending on how many enemies it has spawned and how many you have killed. So when that list eventually doesn't have any objects in it anymore, it knows you've gone through this wave of enemies, it's time for me to spawn the next one. And that next wave of enemies is an array. In that same game, I also have a targeting system where I have a list of all the enemies within a certain range around my player characters at any given time. That list gets regenerated every single frame, and sometimes that might be no enemies, sometimes that might be 10 enemies. So that's why it's a list. On the other hand, I have a system where you can cycle through a number of different weapons on your player character, and I'm never going to add more than 7 weapons. So that can be an array. I hope this introduction to arrays and lists sheds a little bit of light on what you can do with them, why they're useful, and what the differences between the two of them are. Between this video and the last one in this series, we've had a lot of information dense videos, so I think next time it might be time to just have a little bit of fun. It's also going to be a shorter video next time, but we're going to be talking about parenting objects, because that again is a very important concept that you at some point are going to have to understand. And thanks to my patrons, you can see them on screen right now, and a special thank you to my Cave Digger tier Patreon, Syntax.